go along. So let's jump into a little bit about what 5G is. As a consumer, you may have heard a lot about its promises of faster connectivity, low latency, better jitter performance, and all that fun stuff. And for the most part, that's absolutely correct. But about 2 years ago, I started thumbing through the 5G specifications published by 3GPP, which is a standards body that writes specifications for the various generations of wireless standards. And what I started to dig in was something a bit more profound. And I think 5G is very different to us all than what 4G or the transition from 3G to 4G is. So let's go through some of the basics. And then again, if you have any questions, please stop me. So the first is what the move to 5G will have significantly higher peak speeds. So today, and this is primarily through carrier aggregation, mostly what we see on our phones is 100 to 200 megs, depending on where you are. In a 5G world, when it's fully built out, there are expectations that we'll get up to 10 gigabytes per second. So your Facebook feed is going to get a boatload faster. But more importantly, new use cases that will have bigger dependencies on bigger wireless pipes will now be made possible. And use cases that include virtual reality, augmented reality, things that use cases that generate a lot of data and need faster pipes for it to execute smoothly. This will be a great benefit for, and we see that happening primarily in the enterprise world. On the latency side, on average today, 4G LTE networks will see anywhere between 40 to 50 milliseconds of latency, which in itself is pretty quick. In a 5G world, taking advantage of millimeter wave, which is the higher frequencies, you're going to see latency performance of sub 10 milliseconds, which is critical, especially for, again, use cases that depend on that type of speed. Autonomous vehicles being a great example of that. On the scale side, the towers that you see around us today, in many cases, can support somewhere between 10,000 to 100,000 concurrent connections. In a 5G world, that starts to go to 1 million concurrent connections per tower or in a square mile. And that's really important. So if the last time you've been to a Sounders game or a Mariners game or a Seahawks game or concert, what have you, you're in the stands, you look at your phone and your phone shows that it's got full bars, but hell, you can't load data or your phone's acting really slow. The reason why is you've got a high concentration of people all trying to hit similar towers. Our partner T-Mobile has a device called the Cow, which is literally a flatbed 18-wheeler truck that they pull alongside big venues like that to offload some of the traffic from those networks, because those towers and those radios can't support it. In a 5G world, those problems go away, primarily because the capabilities of the RAN, the radio access network, fundamentally so much more significant that you can have a lot more devices connecting to it. And while that's really exciting for our mobile devices, if you look at where IoT is going in a 5G world, and I'm going to lean on Rob to kind of spew some of his insight on this over time in this call, there's almost a 4-time fold of new devices being introduced to networks around the world through IoT, and that's where this figure becomes super compelling and interesting. Now, when you get all of those IoT devices connected to the internet, and GSMA forecasts that by 2025, there'll be over 25 billion new devices on the network. To put that in comparison, in that same time frame, there'll be about 5.9 billion handsets connected to networks. So almost a fourfold increase in the number of connections to wireless networks around the world. Well, those little devices are creating massive amounts of data across the breadth and scale of them. And in today's world with 4G LTE, you're getting about 1/100th of a terabyte worth of data per square kilometer. In a 5G world over the next 5 to 10 years, you're going to probably see that grow to about 10 terabytes. So the network in itself in a 5G world is going to get so much more beefier. But when we look at some of the paths to 5G, there's things that I started to get super excited about and really became the underpinnings of why we launched the 5G Open Innovation Lab. First and foremost, a lot of the networks that we enjoy today are less dense, and in a 5G world, they'll become much more dense. And so I call that network densification, primarily because for some of those speeds and feeds and latency performance in 5G, there's going to be a higher dependency on mid and higher frequencies or millimeter wave. And that means you're going to see a lot more of these little radios that are out and about in city areas and dense urban areas that allow carriers to accomplish those higher speeds. And so networks are getting a hell of a lot more dense as 5G networks start to roll out more and more. And that journey, guys, is going to be a 5 to 10 year plus journey. It's not going to happen overnight. The second is a point that I raised earlier, which is there's going to be a lot more devices connected to the internet, primarily driven, I think, by IoT. And many of those scenarios, in my opinion, will be tied to enterprise. As Jay rightly pointed out, Industry 4.0 is going to have a heavier dependency on data. That data is going to come from new devices that are connected to various parts of a business process that are giving companies real-time insights into either their manufacturing, their distribution, what have you. And so IoT is going to play a much bigger role now, enabled better because of better connectivity. And we'll get into that a little bit. There's a whole new set of new network functions that are going to start to be introduced and rolled out in a 5G world as well, one of which is called network slicing. So think of network slicing as the ability for a carrier to dedicate a slice of their network, a slice of their spectrum to a very specific workload. The example I like to use is Apple, for the sake of its experience for its customers, they may decide that they want a dedicated network slice across all carrier networks. And that network slice is a dedicated slice specifically for Apple users, so they can deliver the best user experience, whether that's in speed, latency, performance, or what have you. Now that a lot of these, the orchestration of these network functions are moving to containerized applications, and because of the specifications in 5G, a carrier now has a lot more control of the radio access network to enable new functions like network slicing. Other functions include dynamic spectrum sharing, carrier aggregation, beamforming, and a few others. That's an example of a new pathway to 5G that gives the carriers a lot more control of their network on the far edge from a radio access perspective. The other big thing that I'm really excited about, and really the genesis behind the 5G Open Innovation Lab, is that much of these new features and performance specs in 5G, while they'll be great for us as consumers, really it's going to have a huge impact in enterprise. ABI Research recently published a paper and presented it about how in the next 15 years, demand for spectrum by enterprises will outweigh demand that currently exists today for consumers. I read another research report that suggests that that carriers will have a bigger dependency on enterprises in various ways. One is in the connectivity through their existing networks, but the second, and this is a growing market opportunity, is that more and more enterprises are looking at deploying their own private cellular networks. And this is obvious in cases where an enterprise like a Chevron, as an example, has remote oil fields or operations where they just want to set up a network to connect devices inside that, and Wi-Fi maybe not the right choice for connecting that. So there is a growing number of, there's a growing number of startups who are building private networking capabilities, and there's growing demand from enterprises to actually build their own private 5G networks. Today, coming out as 4G LTE networks, but in the future, eventually 5G networks as well. So when you look at where 5G is going and you get past a little bit of the marketing hype and start digging deeper into where a lot of the new capabilities are coming and some of these new functions that are going to exist, to me, there's an exciting opportunity in the enterprise world. And for us in the 5G Open Innovation Lab, we wanted to create an ecosystem for enterprise startups to be able to get ahead of that by getting exposed to future 5G networks, thanks to our support from T-Mobile, but also to start to explore what it means to build new 5G apps that could potentially run inside a carrier's network, and app models that are potentially different from what they're used to today. Think of orchestrated apps in big public cloud instances with the ability to orchestrate elements of their applications on the far edge. Now, as I was reading through those specifications from 3GPP, I think it was release 15 at the time, learning more about what's behind or under the hood for 5G, what I had realized was over the 4 generations of wireless standards that have come out, a lot of those networks were essentially fixed purpose networks. So for instance, a T-Mobile would buy great gear from an Ericsson, and a lot of that gear, the core and the RAN, were fixed functions designed for a specific purpose. I'm sorry, my daughter's playing Fortnite, so clearly she won something. But in a 5G world, a lot of those new functions a lot of the underlying technology is being virtualized. And as I mentioned earlier with network slicing, a lot of those new functions on the far edge with the radio are going to depend on orchestration of containerized applications. And so for the most part, guys, carriers are becoming more and more cloud-like in the just the raw execution of their networks over time. And there's a lot of open source projects that are actually taking advantage of where this is going through Linux Foundation. Then there's also an interesting intersection of opportunity as well with the rise in popularity of Kubernetes and serverless computing, and the need for that level of orchestration to happen for functions like network slicing on the far edge. There's a commonality there in Kubernetes interest that carriers could tap into, and that developers and ultimately startups that we're working with are quite interested in exploring. So from my standpoint, 5G is very much a move to the cloud for the carriers. It's a move forward for enterprises to take advantage of what capabilities could exist on the edge for connecting IoT devices and making sense of a lot of that. It's also a great move for startups who are looking to really take advantage of new use cases and explore capabilities that today don't exist, but in future will, thanks to where 5G is going. So moving pretty quickly, there's a few growth opportunities. Some of this is obvious. Some of these things we're working on with startups in our first batch, and as we get closer to announcing our second batch in the next couple of weeks. The first is digital transformation. I mentioned that earlier. Some people refer to it as Industry 4.0. IDC did some research. I believe they were surveying CIOs and CXOs of leading enterprises. And what their research indicated that is that by 2023, I believe, 2023, large enterprises are going to spend about $2.3 trillion on digitally transforming their businesses. And we're seeing that play out even with our partners like Avanade that are having to really fast forward a lot of the digital transformation journeys they had planned alongside some of their enterprise customers. To put that in perspective, 2.3 trillion spent on digital transformation. There's $3.4 trillion spent annually by enterprises on IT services. It was reported by Gartner. This year was forecasted at 3.7, and then due to COVID, it came down at $3.4 trillion. So big amount of dollars being invested by enterprises. A lot of that dependency is going to have a bigger play for IoT. So I think the opportunity for IoT, in my humble opinion, is the horizon of that is actually not too far from us. The second is this private cellular network, something I talked about earlier on the call. Private cellular networks are becoming more and more of a mainstay in enterprises. They're starting to really dip their toe. There is an effort here in the United States that's pretty unique, as you're probably familiar with CBRS. There's been an allocation of spectrum from the CBRS band. I think it's 150 megahertz that the FCC has started to auction off. They did their first round of auctions in July. That auction alone is expected to net the FCC about $40 billion. And a majority of that is expected to go serve the enterprises. So private cellular networks are becoming a real trend. I don't think it's going to be a fad. I do believe that it's going to be part of an IT strategy longer term. Automation is no longer a buzzword. As I mentioned earlier, we have a partner with Avanade that was sharing with our startups back in May, and Jay heard this himself, that they had been working with their enterprise customers on digital transformation journeys that were anywhere between 12 to 18 months out, maybe later for some. And then when COVID hit, in many cases, their customers weren't even able to access their data centers. And so those digital transformation journeys started to come in much sooner, in some cases even 6 months. The reason being is that they weren't able to put people into either factories or people into data centers to actually to execute on their business. And so more of them are now switching to automation with less dependency on human beings for situations like COVID and more dependency on machines. So automation and immersive experiences, the use of augmented reality, mixed reality, virtual reality in enterprises is becoming more mainstream. One of our startups called Tactile has actually an augmented reality experience for the enterprise, and they've got thousands of installs today in the likes of King County and a few other large accounts, including a naval ship, where workers are starting to use augmented reality, capture their frontline knowledge, and share that with other folks. It is not too far of a stretch to suggest that an augmented reality headset could be as important as our PCs are today for doing our jobs. And so those two are big areas where I would say 2 years ago, very much science fiction, couldn't really see a place for this. today, and then certainly in the future, we're starting to see a lot more demand for those technologies emerging. The last is, and this would ring true with this community, if you've got 25 billion devices that are out in the wild that are connecting to networks around the world, your threat vector went from this narrow to this wide, and it's crazy. So just as we're trying to get our hands wrapped around security in the cloud world, in a 5G edge world with 25 billion plus devices expected to be deployed, the risk to security vulnerabilities is so much higher than what we're seeing today. And so from my standpoint, security is a non-negotiable. And in the IoT world, that's going to be a big area that more and more enterprises will likely invest heavily in to ensure that any of the devices that are connected to their networks, that are collecting valuable information, that cannot have any security breaches to, will spend even more money to ensure that those devices are hardened and secured, and all the communications between those devices to an application are equally as hardened and secured. So from my standpoint, security is a big deal in a 5G, post 5G world, and certainly as more devices come online. The last is really the unknown use cases. And I have a phrase here that only time will tell on who will become the next Uber and who will become the next Sears. Really, the use capabilities that we're expecting to be made possible in 5G, the new market opportunities that are really rooted in enterprise, are going to open up the doors for folks like Jay and their startups to really explore in those capabilities and to solve some real problems. Those that can see those problems and solve them early, theoretically the next Ubers. Those that hold on to what the past is and aren't willing to really look around the corner and see what's possible in the future could become the next Sears. So this is an opportunity for us all to think differently. And this is something that I've been pushing alongside our partners. It's probably of no surprise to you all that when when Steve Jobs walked on stage back in 2007, when the first iPhone, and essentially lit up the largest app ecosystem push that we've all experienced, even at my time at Microsoft, there was a big transformation of creating value, for the most part, transitioning over carriers' networks, right? Trillions of dollars of new business opportunities, new capabilities that were created by the likes of an Uber, an Airbnb, or Marketo, or what have you, that essentially traversed over a carrier's network. And that was well and good, but for a carrier like a T-Mobile or a Verizon or British Telecom, Rogers, whomever it is, it's very expensive to build out these networks. In the U.S. alone, the three national carriers of T-Mobile, Verizon, and AT&T collectively carry over $120 billion worth of debt on their balance sheets, and that compares to, I think it's $60 billion worth of debt that Amazon, Microsoft, and Google carry on their balance sheets. So building these networks are super expensive. Seeing a lot of that value transition over your network, not a bad thing for the app builders, obviously, but for a carrier, it wasn't something they benefited from, and they're essentially an interesting and very compelling part of the problem, part of the solution rather. What we're trying to explore here in the lab is to work alongside companies like Jay's and others that are now building some new capabilities that could run directly inside a carrier's network. And it's a bold ambition that we have, but it's one that we've been pushing forward with, that ultimately opens up the far reaches of edge networks by way of just the raw real estate that carriers have, and these new capabilities that are coming online with 5G, as I explained earlier, with a commonality, and I've just indicated Kubernetes as an example of that, but the commonality being that there's a built-in developer ecosystem already that's pursuing serverless computing and containerized applications with orchestration like Kubernetes or Docker Swarm. From my time at Microsoft, the big lessons that I'd learned in my 13 and a half years there is that platforms are enablers for value creation. Apps build the values, those apps pull through the platform. And that's what we're exploring and building out in capabilities for the 5G Open Innovation Lab. So we're focused on building that ecosystem of enterprise startups that are looking to take advantage of new 5G capabilities, working closer with where the edge networkings exist today and where those capabilities will eventually come online over time, and then working with a host of partners that include T-Mobile and Intel and Avanade and NASA, and then we have 3 other new founding partners that we're hoping to make announcements on in the next little while. So I'll stop there.